Welcome, everybody. Welcome to our next abundance webinar, where we're going to be talking about some extraordinary technology, and super excited because this is a subject that I think is so critically important. We are on the cusp of an inflection point. It's an inflection point that's coming as the convergence of a number of exponentials come in. And these are high bandwidth connectivity, which is how we're seeing each other right now around the world. It's going to be sensors, it's AI, it's augmented and virtual reality. All of these things are coming together to create a field of spatial computing, the spatial web, and in particular, on the topic of today, how this impacts the next generation of manufacturing. I'm here with Jim Heppelmann, the CEO of PTC. Our topic is the next manufacturing era. And anybody who's an entrepreneur, anybody who's running a large-scale company that does any kind of manufacturing, this is a conversation you're going to want to be part of. So, Jim, welcome. Good to have you here, my friend.
Yeah, great. Thanks, Peter. I'm very pleased to join you here today and talk about all the exciting things happening in the industrial world.
Yeah, well, I appreciate it. So, you've built a company that's massively disrupting the industry by combining all these exponentials on a SaaS platform. To help clients, build better products. And especially during this time of COVID-19, the ability to use the technologies to really oversee your processes, fine tune your processes, and really, sort of create manufacturing capability of the future. And I'm going to introduce you in just a moment, but I have to imagine this has been an intense period of time for PTC, and a lot of your customers have been reaching out to say, how do I do this? How do I operate during this incredibly complicated time?
Yeah, I mean, I think what we're trying to do is create a digital twin or a digital mirror image of, if you will, of a product or of a factory or of a customer site. And of course, all of that is very powerful ideas here in this COVID era. So yeah, customers for sure are really interested in saying, how can I work differently so that I could work around some of the COVID challenges that we're suffering?
Yeah, and I think ultimately everything that's been happening in the last 6 months has sort of accelerated every business by years, let alone in the better part of a decade. So let me begin. So everybody, get your questions ready. I'm going to interview Jim for the first 30 minutes, then really open it up to you. But again, if you're in any form of manufacturing, if you're interested in how augmented virtual reality is going to impact our sort of entrepreneurial world, or if you're an entrepreneur looking to be able to mirror a great CEO, stay tuned and let's jump in. But first, a quick and appropriate introduction for Jim Heppelmann. So Jim is the CEO of PTC. He's driven the company to assemble the industry's leading industrial innovation platform and field-proven solutions that enable companies to design, manufacture, operate, and service things for a smart, connected world. And I would imagine that much of what you're building with PTC wasn't even possible, 3 years ago, let alone a decade ago. Jim's emerged as one of the thought leaders, having co-authored multiple influential articles on the IoT, Internet of Things, augmented reality, the future of smart and connected products. Jim, you've been named one of the top 7 IoT leaders back in 2017, an IoT CEO of the year, technology CEO of the year. And I've been to PTC's major events of the year, and it's pretty extraordinary. So thank you for joining. And I want to dive deep, ask you some hard questions, and really try and understand the vision of where we are now, and importantly, what's going to be possible in 3 years, 5 years, and maybe push you on sort of a decade out. Is that fair?
That's fair. Let's do it.
Okay. All right. So let's kick this off. So if I understand properly, your customer base is manufacturers, people building things, and so the question is, what are some of the biggest challenges that you've seen them face and navigate during the pandemic? I mean, imagining supply chains have been disrupted, and people are trying to do things with more robotics and automation. So what's going on right now?
Yeah, I think, Peter, the first thing that is easy to forget about is that most manufacturing companies have far more frontline workers than they do knowledge workers. So those of us who are knowledge workers, we all went into this work from home mode, but
Yeah.
factory workers can't work from home. You can't assemble an automobile in your, in your home office. So there's a lot of frontline workers involved, in manufacturing and installation and customer service. There's health risks there, and of course, if you shut that process down, all your revenue gets shut down with it. So that's one category of problems. A second category of problems is supply chain disruption. First from trade wars that sort of created COVID, and then more recently, supply disruptions from companies that either suppliers that were shut down or perhaps shipping routes that were shut down. And then, I think the third problem to layer on top of all that, to keep in mind while you're trying to fix those problems, is that the economy is terrible. And a lot of companies have seen their own results suffer. So they're trying to figure out how to be very cautious with investment because there's not much to invest, but at the same time, fix some pretty big, very much disruptive problems in their business.
And I can also imagine right now, what people need and want today is changed over time. So, one of the things I keep on when I'm mentoring CEOs and entrepreneurs, it's agility that matters more than any time ever before. Yeah. And so I would also include agility in what products you're creating and your manufacturing processes and so forth. Can you speak to that a little bit?
Yeah, for sure. I mean, that's a good point. I think a lot of the technology that had been used by manufacturing companies it took a long time to set up. And so, for example, if you wanted to have a supply chain working on a design together, everybody had to implement and set up the same version of the same design software, which takes a long time. So if we all agree we're going to work together now, it may take us a month before we collaborate for the first time. So I think what happened in the COVID timeframe is all of those types of systems were sort of blown out of the water. And in a context of like health emergencies, people said, we need new ways to work together right now, like this afternoon. So certainly SaaS technology, for example, took a huge leap forward in our industry because, if you want to pull 2 or 3 companies together to work on an emergency response team to create ventilators, I mean, we don't have a month to put infrastructure in place, but we could all use a common SaaS system right now. So a lot of companies said, okay, it's time to think beyond these installed on-premise software systems that have so much friction and really try to move to a frictionless SaaS environment where we can all collaborate immediately. We saw that, by the way, in academia as well, even more so, because all these schools that have students who are sent home, a lot of the technical software used in the manufacturing industry is PC based. And actually, most students don't have PCs these days. They have MacBooks, they have iPads, they have Chromebooks, and they couldn't use the software from home, and they couldn't use the software in the computer lab at school because the computer lab was locked. So what to do? Again, the answer is SaaS. Let's use something that doesn't have an installed footprint so that we can all just log in and participate. And so PTC really has done a good job partnering with schools, I mean both universities and high schools, to reinvigorate their STEM programs around the SaaS technology. And students can use it from home, they can use it from the dorm, they can use it in the computer lab, whatever. We've just broken the ties, if you will, to that desktop computer that was so important in the previous era.
Yeah, no, it's super, super powerful what you can now literally do given high bandwidth. You don't have to have everything resident on your machine. So the term digital manufacturing, I think, has changed a lot over the years. I used to think digital manufacturing was just 3D printing. And how do you define digital manufacturing?
Well, I think, there are a couple of point solutions. There is 3D printing. There is automation in the factory. But I think the cutting edge stuff now is being able to collect data from machines and workers, understand what they're doing, how could that be optimized, and then provide feedback to both machines and workers to help the process work better. How to kind of like digitally monitor, perhaps from a remote location, and then coach machines and workers so that you get more work done, high quality work done faster. And to me, that's digitizing everything. The product's digitized, the manufacturing environment's digitized, what's happening on the customer side is digitized, and you're monitoring that. It's really kind of a closed loop connection between what's happening in the real world and its digital twin, and then information flowing in both directions.
Yeah, I think that I've got to imagine that stuff has moved forward I mean, I'm gonna, because I'm tracking across all exponentials. I am curious because I'm gonna use you as the expert far more in this. And in the manufacturing world, in terms of bringing exponential tech to changing manufacturing, how far have we moved compared to what your team's expectations were and your expectations were over the last 6 months? How far have we moved forward, do you think?
Well, I think, the IoT set of technologies that allow us to collect data and to apply machine learning and AI to it and to see patterns and circumvent problems that are developing and so forth. They have that closed loop monitoring and optimization system. That's very exciting and has come very far, very fast. What's even more exciting, though, is augmented reality, which I always say is like IoT for people. You can't connect people to the internet because they don't have an Ethernet port, but they do have 5 senses. So to the extent you can represent digital data as something they can see or hear in particular, you can deliver digital data to them on the front line to coach them and guide them and instruct them and mentor them, what have you, and also collect data back as they're doing the work. Did they do it right? How long did it take, etc.? So I think that augmented reality is really exploded for 2 reasons. One is connectivity, but the second is cameras. In order to guide a person in the frontline world, you need to have computer vision that can see the frontline world in real time. And of course, the cameras that are on your phone, we all know this. I mean, we now have depth sensing cameras on the phone in our pocket or our purse. It's unbelievable. So camera technology has come so far, so fast, whether it's phones and tablets or smart glasses, that suddenly we can kind of digitally immerse ourselves in the work environment at the front line next to the frontline worker, and as if we were there and coach them and assist them and so forth. Very, very powerful technology.
Yeah, it is. And it's in parallel, it's coming to the consumer as well, to the large corporations. And, I've been tracking for ages what obviously Microsoft, who you have a great partnership with Microsoft on the HoloLens. We've seen a number of bumps in the road for Magic Leap, but coming from the quiet rear view mirror, accelerating at warp speed is Apple, which you've also been working with. Can you talk 1 second? Who are the AR players out there that you're most excited about, and what can you tell us? What secrets can you unveil?
I would put Microsoft and Apple at the top of the list, but for very different reasons. Microsoft, because they have the best hands-free smart glasses type of device, the HoloLens. That's the best one out there by far, and you can really do some powerful things with it. Now, we need to see the next generation and the generation after that before it really becomes sort of probably more mainstream. Let me switch to Apple for a minute. What Apple's done is democratized it, because everybody has a phone or a tablet, but let's say a phone. And that phone has an amazing battery and a high definition screen and a super powerful camera. And so everybody now in their pocket has an amazing AR device. I mean, you have one right now. I have one right now. Everybody listening to us has an amazing AR device, within a couple of feet of them. And a lot of people say AR, I mean, that's been around forever. Yeah, but we didn't have a democratic device of that level of power and capability that we now have. So HoloLens is great, but actually most AR stuff is happening on sort of run-of-the-mill phones and tablets.
Yeah. What do you think of the technologies that are making, if you don't mind, just let's take a moment to just identify the tech that's enabling this next generation of supply chain and digital manufacturing and automation that you're doing. So clearly it's sensors. It is sensors on the factory floor, cameras and such. 5G, how important is 5G these days for you?
Well, 5G is important for a couple of reasons. First of all, it's faster and we take latency out of them. But the second thing is it's generally much more mobile than a lot of the devices, the machines in factories have been connected with Ethernet cables, which of course is very limiting for anything that wants to move around. And if you switched off the Ethernet cable, then you went to Wi-Fi, which brought up latency problems and whatnot. So 5G gives us connectivity now that's both wireless and super fast. And whether we're using that for AR devices or using it for robots driving around a factory floor, either way, it brings a lot of value. So definitely 5G is a key technology.
And of course, the monster force du jour is computation and AI behind here. How are you, talk to me 1 second about both of those in what PTC is doing.
Yeah, for sure. I mean, computation allows AI, and AI shows up a couple of different places. One is computer vision. If I want to tell you what to do, I need to see and actually recognize what it is that you're doing, the environment you're in. I have to locate against that environment. And that really requires, deep learning algorithms that look at every frame of the camera that you have in your hand or on your head and keep monitoring, what's happening there. The second thing would be machine learning, particular IoT. If I'm trying to get data from machines or assets or products, I mean, what does it mean? I always tell people, think of it this way. As humans, if you're old enough, you probably drove a car at some point that had a slipping alternator belt. And you said, oh, that squealing sound sounds familiar. So that pattern of sound waves sounds familiar. I've heard it before. And I'm pretty sure it's a loose alternator belt. And last time I had a loose alternator belt and I ignored it, I ended up with a dead battery. So this time I'm going to go figure out why I have the squealing sound. I mean, that's just the human brain doing exactly what predictive analytics is trying to do: recognize patterns, correlate patterns to previous events, understand, therefore, what's likely to happen and how far down the progression are we toward that problem, and then try to figure off some kind of intervention, fire off some kind of intervention of man or machine or whatever to try to solve that problem and prevent the downtime from happening. I mean, it's a powerful concept, but, we need computers to do a lot of number crunching in real time to deliver a concept like that.
I have to imagine, I mean, what percentage of manufacturing companies are beginning to see the need for this and are beginning to upgrade and update themselves? Because, I'm of the belief, I tell people, listen, if you're not fully utilizing AI and other exponential technologies by the end of this decade, you're out of business, right? Yeah. And it's just that fundamental. How many companies are still old school, so to speak, out there percentage-wise?
Yeah, I mean, I'd probably say a majority, more than half anyway. But I'd also say that the number who are really seriously investigating the technology is climbing quickly. For us, it means lots of demand. But I think, the benefits are profound. If you can take a factory that costs you $200, $300, $500 million and make it 10% more efficient or 40% more efficient, I mean, it's a profound benefit. And maybe you don't have to build that next factory because it turns out you actually had a hidden factory in terms of lost productivity. Just a quick anecdote. I went to a customer site where they were going to present a smart factory project to the CEO and the management team. And the project manager kicked it off and he was a little nervous. He said, I have good news and bad news. And he said, we did this project in our best factory, what we all agree is our best factory. And the bad news is it's only 25% efficiency. The OEE metric is 25%, which is terrible. And he said, but the good news is, at least we know it now, so we can stop lying to each other about how effective and efficient it is and actually go make it better. So I think that's the kind of benefit that's out there.
So someone comes to you, they're running an old style, however you want to define that. How do you get them on the on-ramp to get started? What is the tech that you have to, you have to get them on the cloud, first of all, right? Yeah. You have to, so talk 1 second about how you go from 0 to 1 in this.
Yeah, I mean, our ultimate goal, let's say with the factory, is to connect both the assets and machines and the workers and to be able to, even capture the space that they work together in so that we understand not only where they are, but what they're doing, both human and machine-wise. Now, we can't do all that at once. So sometimes we're starting with the people and we're really saying whether it's a manufacturing worker or a service worker, bringing augmented reality into this discussion could make that worker, 30, 50% more productive.
Which means what? You put a headset on them with forward-looking cameras, and someone can advise them?
Ideally, or we do it with phones and tablets because it's so much more democratic again.
Yeah.
The problem with the phone, the real problem, is it ties up your hands. So it actually works really well for augmented reality. It's just you can't have a part in one hand and a wrench in the other unless you have 3 hands to hold the phone. So think of the HoloLens as, kind of a phone mounted on your head, more or less. I mean, it's more than that, but conceptually. So your hands are free. So you can take all this guidance and coaching and instructions and so forth while using your hands. Otherwise, you have to get some instructions, guidance, set the phone down, work on it and pick it back up and
okay. So the first thing is giving the employees this kind of superhuman capability. It's almost like having the world's expert sitting on your shoulder saying, see that over there, go and remove that piece and change this over here. So that's great. What do you do next?
So we could start at the other end, which is doing the same thing with machines. Start by collecting data from new sensors, but in a lot of cases, there's a lot of sources of data that are used to control a machine locally, but not shared with anybody. PLCs and control systems. So in a lot of cases, we're tapping into that and doing the same thing, saying, give us a data stream from the machine so that we can understand how efficient and effective it is. And then on both sides, we could apply AI. Obviously I talked about predictive analytics for a machine, for example, to understand, is it drifting out of spec and it'll soon start making bad parts? Is it beginning to experience a maintenance problem and it'll soon, go into a shutdown mode? I mean, to try to, prevent those bad things from happening and understand how effective and efficient the machine is. For workers, we can do the same thing. There's some new AI tech, for example, that says, hey, if I tell you to put a cap on a bottle, now, first of all, I can watch your hand motion to see if your fingers are turning right as you put the cap on the bottle. And then as soon as you pull your hand back, I can look at the bottle to see if it has a cap on it, right? Using the same AR technology. So it's both able to guide, but also kind of inspect the work to make sure that the humans are getting the right result very quickly as well.
So, and it's interesting, right? Because you would think this is obvious to be gathering the data from your machines and being able to analyze the data. But, and we talk about in an AI world right now, data is the currency. Unless you can collect the data, you don't have the ability to optimize. You can't impact what you can't measure. And I would guess it's amazing how few companies actually measure everything they can.
Yeah.
Interesting.
Yeah. I think back to the Frederick Taylor days, back in one of the previous industrial revolutions, you'd have somebody sitting there with a stopwatch timing, a process to see when did it start, how long did it take, how much dwell time was there before it started again. And of course, that data is what allowed manufacturing to become so efficient in the first place. But the problem is it takes a dedicated person with a stopwatch. So think that we've replaced that dedicated person with a stopwatch with stopwatches everywhere all the time, monitoring what's happening with machines and workers to make sure the process is flowing efficiently and always looking for where's the next bottleneck. How can we make it better? Even if it's good, it could be better, but we got to find the long pole in the tent.
You had shown me earlier a short video clip of what this actually now looks like in the in a company. Do you mind taking a second to
give me just a second? It's a minute and a half clip. Pretty exciting stuff in my view here. Let me see if I can pull it up here. Well, maybe I can even run it this way if necessary.
Yeah.
So this is the concept we call spatial computing, and it starts in a lab here at our PTC headquarters. And that's just a room that's got some machines and workers. Here we've created a digital twin of that space, and using Microsoft Kinect cameras, we've illuminated it in real time. So it's a real-time 3D model, and therefore we can fly around in it. So I'm in what some people would call God mode, where I'm flying around. Here I'm in the physical space, and now in a second here I'm in the digital space. And just trying to show you it's not actually that much different. The thing is, I can do the digital space from 1,000 miles away, and I'm collecting data already, but I'll show you in a minute how it gets a lot more interesting. So here's a worker, a human worker and a robot. What I've done now is anonymize both of them. So I've turned the worker into this green stick figure, if you will. And I've started turning on some analytics to say, where does she spend her time? And the darker those cubes are, the more time she spends. Now I'm saying, tell me more about the process, the stopwatch kind of thing. And I should have, let me just stop this just for 1 second. Get rid of this stuff that's kind of in the way. And jump back into it here. So again, here's the hotspot. Now I'm gonna say, tell me when she's in this space or that space or that space. And in fact, in my process, I'm gonna identify step 1, 2, 3, and 4, and 5, and now collect data as the robot and the person works in this space. What are they doing? How much time do they spend? And actually give me a waterfall of the time spent by the person, the robot, how much time is in motion, how much time is spent doing different things, and let me see that waterfall of where the time was lost in this process, because that's what I'm going to have to go after to try to make the process better. So it's a very powerful concept where I'm watching people and machines work together in a process in a 3D space, and all of that can be delivered and experienced virtually, sort of as we are here right now. So I think it's kind of an interesting concept, and maybe starts to show the depth of what's coming, what's possible.
Yeah, I mean, it is bringing optimization capability, and you can't optimize what you can't measure. Another optimization capability that I know PTC has been working on is a field of generative design, which I find absolutely fascinating because it's as beautiful as it is impactful. Could you take a second and discuss that?
Yeah, I always like to say, if you look at how Mother Nature designs things, like take the skeleton of a bird, it's a very interesting, very, very complex design. But Mother Nature had many millennia to perfect that design, and we humans don't have that much time. So we tend to make designs that are much more square and blocky, and we work backwards from what we know we can manufacture. Some of those shapes in that bird skeleton are extremely difficult to manufacture. So what generative design does is it kind of uses computing power to look at the design the way Mother Nature would and grow the design. And so a human sets up the problem. Hey, I need a part that connects these two things together, doesn't go outside of this space envelope, can carry this load during this motion, and give me a design. And so generative design really iterates through like Mother Nature would, but in the course of minutes and in some cases an hour or more, and comes back with not only one design, but maybe a series of choices. Like if you want to make it out of steel, this is the best design. If you want to make it out of titanium, this would even be better, but it's expensive. Or if you want to print it, here's a design. Or if you want a high volume subtractive manufacturing process, this is a good alternative. And so generative design is like Mother Nature looking over your shoulder, done digitally, and coaching you through some design concepts that, trust me, no human's ever going to figure out by themselves. But it produces really interesting designs.
I love that. And just for everybody, please get your questions ready. We're going to go to you in just 5 minutes. So Jim, I think about the future of manufacturing, and it's really a convergence of all the things that PTC is doing, that there's some point in the future where if I have an intention, I can turn that intention into a physical thing, right? I can say, I'd like something that's going to hold my phone, and I want to have it, be super lightweight, and I would like to have it thermally insulating. And I can describe what I want, and I can start to almost in augmented reality see it and as I give my AI different intentions, and can you color it red, and can you put a handle on the back, and I go from my descriptive mode to something that is created, and I say, price that out for me, and I say, can you make it cheaper? And can you make it, out of whatever materials? And all of a sudden I say, yes, that's it, print. How far are we from that kind of a?
Yeah, we're not far. We're not far from that right now. I mean, I think we can do that with simpler cases, but clearly where the industry's headed is you give me the requirements and maybe the constraints. Like the constraints might be the volume you need to produce or the cost per unit. And the requirements would be, it needs to hold the phone here, and it needs to attach here, and it needs to hold a certain amount of, when I grab the phone, it can't break, and so forth. So those are the requirements. And we're getting close to the point that we can solve a design against the requirements without violating the constraints. And again, give you 10 ideas back. You choose which one you like the best.
Yeah, I mean, it's really
that one, we'll hit print.
It's a democratization of design, democratization of manufacturing. And it's a beautiful thing where people can start to make N of one devices if they need. That's beautiful. But so where are we going? I mean, I spend my life inspiring, guiding entrepreneurs and helping CEOs sort of see over the horizon. 3 to 5 years, 5G is now ubiquitous. We're heading, Ray Kurzweil talks about human level AI by 2029. We have Apple entering strong with their AR tech in the next 2 or 3 years. We've got not only 5G, but we've got Starlink giving us global connectivity. 8 billion people connect on the planet. What else is going on? quantum computing is coming online. We see a lot of progress right now with quantum computing, reducing noise rates and getting to significant qubits out there. I won't go into molecular, but material science is also progressing at the same time from machine learning. What are you excited about in like a 5-year horizon?
Yeah, I mean, I tend to think in terms of this mirror world or digital twin, if you want. How big and sophisticated can we make it? Because we can make a pretty good digital twin of a product or a factory or a customer site. But what if we had a digital twin that was the product as it was being made in the factory and delivered and used at the customer site? So maybe a question is, how big and powerful can we make these digital twins? And of course, there's some ethics concerns we got to work out here as well. But to me, the digital twin simply means we have a digital representation of some physical situation, and we're synchronizing the two. So what's actually happening in the physical world is being brought into the digital side, where we can apply all this computing and AI and so forth, and then provide instructions and guidance back into the physical side and just keep that loop going, where it's sort of like the right brain, left brain almost concept, where there's two different brains here guiding everything that happens.
I love that. I mean, and just we're going to have a seamless portability between the real world and the virtual world. That becomes extraordinarily powerful. Yeah, I love that. Claire, do you have any questions being teed up from our community here?
Yes, we have quite a few. I can go ahead and get started.
All right. I don't want to steal time from them, so let's jump in. That's the fun part.
So we've got a question here from Elma, who asks, which PTC products do you potentially see being used in construction? For example, office supervision of construction site work.
Yeah, I mean, certainly our IoT platform, ThingWorx, and our augmented and virtual reality platform called Vuforia. Less our CAD and PLM platform, because they're designed more for mechanical products. But of course, the connecting of the physical and the digital worlds, both machines and people with IoT and AR, that's something that is a quality we can bring to any environment. So there's a technology out there, by the way, called Vuforia Spatial Toolbox, which was in that video clip I was using. That is open source technology. You can go to our website and search it and find it, download it, play with it, build your own apps and examples. Probably could build real-time construction monitoring spatial capability as well if you're really energetic and ambitious.
Great. We have another question here from Elton, who asks, one of the topics that excites me most is technology's ability to retool our workforce and democratize access to certain professional skill sets. Jim, I'd be curious to know if you think SaaS and AI and AR platforms will enable unskilled workers to more quickly and easily become engineers, technicians, and the like.
Yeah, for sure. And in fact, I think what's happened is we've created a big gap between knowledge workers and frontline workers. And knowledge workers have digital helping them, and frontline workers kind of don't get any benefit at all from digital most of the time. And that's because we deliver digital information on computer screens. And frontline, knowledge workers sit there and look at a computer screen. Frontline workers don't. So I think AR to me is about stop augmenting the computer screen with information and augment the real world with information, so somebody's in that real world can get that information in the context of their work. Let me share a fun example that I like to use to get people thinking. And I'm not trying to say it's practical, but hopefully it's a little bit mind opening. So let's say I wanted to play chess against the world masters, and I want to play Garry Kasparov, but I want to play him actually at the Starbucks down the road. So problem is I don't actually know how to play chess. And to get good enough as a frontline chess player, because that's happening in the physical world, that's why I said at a Starbucks, it would take me decades to jam into my brain everything that might happen in a chess game so I was as good as Gary and could beat him. And maybe I never will. Meanwhile, some years ago, IBM created this computer called Deep Blue, which if Gary plays on a computer screen, Deep Blue can beat Gary all the time. So what if I had smart glasses, look something like this, maybe from Apple in the next year or two, and I could put them on, and these glasses were talking to Deep Blue. And Deep Blue said, hey, Jim, take this piece and move it there. Okay, Gary, your turn. Now, Jim, take this piece and move it there. I would beat Gary every time at any Starbucks he picks. And the key thing is, Gary might say, wow, Jim, you're such a good chess player. I'd say, no, actually, I don't even know how to play chess. I just have a digital helper who's helping me, the same way we help knowledge workers, but it's helping me in the real frontline world. So I think that what we're going to do with augmented reality is going to take frontline workers up so many levels that we're going to begin to question some automation strategies. We're going to say the problem with automation is the setup costs are so big. And the advantage of humans is they have very little setup costs. We can go from driving the car to cooking dinner to eating dinner to doing dishes in 30 minutes without missing a beat. If you tried to program a robot to do that, it would take months to go through those different motions.
I often imagine, Jim, a future, I'm always thinking about how do we create work in the future, right? The future of jobs and so forth. And I always imagined a large factory setting where anybody who needs a job walks in and they're just given a pair of glasses.
Yep.
And they go stand over there, and all of a sudden they say, okay, we're going to have you assemble this thing, repair this thing. And you start as someone able to, be well coordinated and be able to follow instructions. You've got a job doing something. And the more you do the same thing, the more you learn. And it's also teaching you in the process of doing that. So I think that's going to be a fascinating impact.
Yeah. And sometimes there's a big AI engine at the other end of the glasses. Sometimes it's another human, maybe who's working from home, or maybe somebody who retired last year, or maybe it's even digital artifacts captured from somebody who retired 2 years ago. And I'm just reusing the digital artifacts and they're coaching me through the process, even though they're long gone, in terms of employment. So it's a big, big, big idea. I think it's going to be very, very transformational.
Claire,
so actually, two questions related to this very topic. One is, do you see the digitization of the factory enabling a gig economy component to contemporary factories? And then the second question that relates to that is, I'd be curious to know if PTC has considered any models for incorporating a gig economy component in the next manufacturing era.
Yeah, well, first of all, I think if you look at some of the key building blocks for a gig economy, number one, most gig economies have an underutilized asset. Like Uber praises or builds on the fact that most cars are not driven 23 hours a day, but could be, right? And the second thing is you need to have people be able to get into the gig and back out again without too big a startup cost. And so, I was mentioning the idea of SaaS. It takes away a lot of the startup costs. AR takes away a lot of the startup costs. 3D printing takes away a lot of the startup costs. Generative design takes away a lot of the startup costs. So I think these are all enablers that says somebody with a good idea could engage quickly, and digital could help them with the design. Digital could help them with the manufacturing, with the assembly, with the installation, with the use of such a product. And they become, gig entrepreneurs, actually gig manufacturing company entrepreneurs, right? So I think it's definitely interesting. I mean, it's probably a little bit ahead of us, but I think that the pieces are lining up, the stars are aligning such that it could actually happen.
Jim, over your left shoulder, is that a generative design object, or is that artwork?
Maybe I'll pull it up. So this is an example. I was mentioning that they look a little bit like Mother Nature made them. So this is an example of a ski bracket from a Polaris snowmobile. And the human design one would be very square and chunky. By the way, it would weigh about twice as much and be no stronger, right? So this is a very, very efficient design. But again, not something that you or I could sit down and come up with because the curvatures in the design is just too complex. Again, looks a little bit like a chicken carcass, right?
I love it. It's beautiful. Yeah. Claire.
So we have another question. You've talked about AI in the generative design space, but curious to know, how will AI affect materials engineering?
Well, so of course, the way this generative design works is it's actually simulating on the fly using high compute power to do real-time simulation. So it's simulating and evolving. And one of the parameters is the material properties in that simulation. So you can actually say, here's a set of materials you could play with, or here's a specific material, or even come back and suggest to me certain materials that would best solve for what I'm trying to solve for. So definitely that's like one of the key parameters of both the requirements and or design considerations.
Fantastic. So we have another question about the future of work here from Vivek, who asks, when and how do you expect engineering education to change to make it possible for graduates to someday run factories without any machine-facing workers?
Yeah, well, I think
fascinating.
I think there's a couple of different pieces to that question, and I actually want to poke a little bit at the premise of the question, because I'm not 100% sure that should be the goal, is to take all the workers out. Because again, the startup costs for automation are so high that by definition, you have to have massive volumes of production to amortize them. Whereas the startup costs, let's say for printing, are very low, but it's not a high volume process. So sometimes that's a problem. But the startup costs for people are very, very low. If you want to make one loaf of bread, don't buy a robot. Just go make it, right? And let me show you how. So I think that we have flexibility now to say automation is good at this. Workers are always had strengths in terms of creativity and startup costs and so forth. But now we bring digital to workers and turn them into superhuman workers, and they actually can do much more than they ever could before. So we have to rebalance. And then what I would say about education is I think that the workforce of the future is already switching to this way of thinking. You know how phones, for example, smartphones like iPhones, companies didn't get into that game first. Consumers did. And they brought their phone to work and they said, I want something like this. And I think if you look at technology students use, let me use an example of Google Docs. Every student out there uses technology like Google Docs, which is SaaS-based and collaborative, multi-users working on the same document at the same time. And then they get a job in industry and told that's not how it works here. And they just think you're dinosaurs. I mean, we're dinosaurs. I'm a dinosaur. So I think that the new generation in schools is being exposed to technology that's 5 and 10 years ahead of what their parents are using at work every day. And I think there's going to be a moment here where companies are going to have to say, how did that happen? How did we miss all this stuff while all the new workers, maybe the disruptors, embraced it and really are using it to create, whole new ways of thinking, whole new kinds of companies.
Great. Another question here from Max. You mentioned PTC's Vuforia product, and I'd love to hear more about the Vuforia iPhone app that allows people to play with examples of AR in their own living spaces. When do you think AR will reach an inflection point of becoming seamlessly accessible to users, or reaching an interface moment, so to speak?
Well, I think we're there in certain use cases. For example, we have a product called Vuforia Chalk, which during the COVID timeframe, we just made freely available because it was so powerful to manufacturing companies who needed to pair an expert up with a frontline worker to solve a problem. Maybe it's a machine's down or this person is having a problem or needs some help or whatever. And so what this Vuforia Chalk product does is in a video call, you don't have the video look at your face. You have the video look at the frontline environment in front of you. And it's dynamically using AR and computer vision is creating a 3D model of that environment such that the remote user can say, see this lever, you need to turn it this direction. The remote user is drawing with their finger, but the actual annotations end up on the lever on the machine. So if you pan around, they stay stuck on the lever on the machine. So that's kind of the best example of a AR enhanced video call. It's like a FaceTime call, but with AR, and it's just as easy to get into and get out of as a FaceTime call, but so much more powerful when one person is in a frontline environment where seeing their face doesn't count for much. When I'm playing Gary Kasparov in chess, seeing my face isn't that helpful. I need you to look at the chessboard and see the move he just made, right? So this is a good example. Check out Vuforia Chalk. You can download it and play with it. Takes 2 to play though, because it's really a collaboration technology.
Nice.
Great. So a question more in the economics realm. How much more cost effective do you think digital manufacturing will be in the coming 3 to 5 years? And might this cost effectiveness even bring some outsourced manufacturing back to the US? Yeah, for sure. I mean, I think factories have an opportunity to become, 50% more productive, let's say on average.
Wow, that's a big number.
you got to start with how unproductive they are right now and how little understanding there is of that. But I'd say the actual data from actual customers would say, if you got a factory that's 70% productive, I mean, that's best in class. At 70% productive, right? And even there would be practically room for 50. But the average one's much less than that. So here's what I would say. If you're going to reshore, you better go investigate this technology right away, because you're going to lose the advantage of labor cost arbitrage. And the only way you're going to make it up is through the right combination of digitally enhanced labor and automation working together in an extremely efficient process that more than pays back what you lost in labor cost arbitrage. So I think there will be some reshoring because people are sick of the trade wars and the supply chain disruptions, but it's going to drive a lot of technology. It has to.
Jim, where do you drive most of your innovation? How, I noticed nicely that PTC's stock price has come up since the low. Congratulations on seeing through that storm. That's beautiful, and it's doing very well. How many employees do you have now in all of your companies?
We have about 6,500 employees globally. Around 1,200 in theory at our corporate headquarters, but of course most of them are actually working from home.
And how do you drive? I mean, PTC is a cutting edge innovation company, right? You're constantly looking at what's possible and how to apply it, and you're sort of like the front line for manufacturing companies, right? They depend on you to think through what's possible. Are you buying innovation? Are you driving it in your labs? Are you investing in it? How do you, as a CEO, how do you think about being on the cutting edge of innovation?
Well, I definitely say acquisitions of small startup companies are very important, because that shows people that have initiative and drive and good ideas. They build something surprising. And then, we look at it and say, well, we could try to copy that, but do we have the initiative, the drive, and the brains? Or we could try to acquire them and bring them into the fold. So certainly we do hire a lot of people, a lot more than we acquire. But acquisition to me is always like, how do you take step functions, improvements? You acquire something that already exists and, has had a lot of good investment and ideas put into it. But then definitely, we're in some of the best tech hubs. I love Boston. As Peter knows, we have some of the best universities in the world here. Places like MIT and Harvard, where Peter has degrees. But we're all over. Some of the best computer vision technology in the world is developed in Zurich. So we have a lot of people in Zurich because there's great university programs that pump out people, and we bring those people right in and put them to work the next day and so forth. So it's kind of a combination of step functions done via acquisition, many times of small companies, because they tend to be early stage, and then good hiring in and around all that to build and commercialize that into product suites that solve actual real world problems.
Nice. Claire, back to you.
Sure. So we have another question here from Marion, who asks, could you touch on some of the trends you've studied in the industrial IoT space, and what have been the greatest accelerations of sensors' role in manufacturing facilities? Is the name of the game the sheer volume of sensors or something else?
No, I don't think, it's one of those cases where having the right data that helps you understand where the bottleneck is so that you can remove the bottleneck is key. Now, a lot of times you don't know necessarily what that data is. And in a lot of cases, the data is out there. It's just never been really collected. Like these control systems are filled with data. They just historically haven't shared with anybody, but they could. There's actually the capability to do that. So I think you have to have a thesis as to where the problem is. And then I think you have to collect data to prove or disprove your thesis, and then narrow in a little bit more, maybe collect some more data, try to narrow in on a bottleneck. In a effort to have continuous improvement, every time you solve the worst bottleneck, you kind of have to move on to the second worst bottleneck. That bottleneck solved, but the process didn't get that much more efficient because there's a second worst bottleneck that's nearly as bad. Now we got to identify and go solve that. So to me, it really gets back to automating this whole stopwatch kind of idea from, 100 years ago. And really trying to figure out that how do we measure what's going on and understand what's going on so we can then look for ways to improve it and remove the bottlenecks. It isn't just volume of data, it's having the right data and then applying the right kind of analytics and so forth to help you get to the root of what the problem is so that you remove the problem.
Sure. So we have about one or two more questions here. One is, in the current new normal, do you see any reason why AR has not been used more in the sports, entertainment, and fan experience where stadium stands are empty? Is it a cost factor or a technological constraint?
Well, yeah, I mean, so AR always, it has been used for a while in a simple way, which is, for example, if you're watching a football game and you see where the line of scrimmage is and the first down line augmented onto the playing field, and when a player stands in front of that line, the player obfuscates the line, not the line obfuscating the player, and so forth. So there is some use of it, but yeah, I think that's not my field. I don't spend enough time studying that particular problem. I have thought before that if you were in the stadium, AR would be immensely useful, because think of, some of us like to watch the games on TV because of all the analytics and analysis of the play, the chalk talks from John Madden kind of thing. You don't get that when you're there. But what if you pointed your phone at the field and you did see the same kind of information annotated on the physical playing field? There's lots of opportunities there. I mean, I think that's a business that maybe somebody on the call ought to go chase, because it's a little out of my wheelhouse. But certainly it's another case where there's a lot of information available to people in the digital world, but not available to people in the physical world. And AR could bring it into the physical world, again, analysis of the play after the fact, for example.
Jim, are you seeing the speed of new designs, of new product designs accelerating? Again, I'm looking over your shoulder. I see the Vision Jet over there. I don't know. Are you a Vision Jet pilot, or just
not a Vision Jet pilot, but a Cirrus pilot, and Cirrus is a customer. Yeah.
Yeah, I'm a Cirrus pilot too, and I'm got my eyes pegged on getting a Vision Jet locally, because I've flown and I love it. And I think about just it's it's an extraordinary machine, to put a plug in for them, what they've been able to pull off in this new generation jet that's going to make air taxis very possible. But I think about this, how long it has taken to go from an idea to actually something on the production plant. Are you palpably seeing that accelerate and get faster?
Yeah, for sure. I mean, what slows Cirrus down more than anything, I think this, is regulation. Right?
Yeah, the old saying, the FAA is not happy until you're not happy.
But I think in non-regulated industries, the pace of innovation is blistering fast. And I think in regulated industry, like aviation, like medical devices, the FDA, the FAA just slows it way down, which is kind of unfortunate. And I hope at some point there's a bit of a reconsideration of their role. They had so much overhead and paperwork and sort of last generation processes being layered on top of next generation designs. It's a bit frustrating. But outside that, if you look at what's happening in the automotive world, the industrial world, the consumer products world, things are moving really, really fast.
Yeah, and I just think about, again, for the entrepreneurs watching here, the tools that PTC is enabling to allow you to go from I've got an idea to I'm selling a product, right? To be able even to test a product digitally and see if it's worth actually, to simulate it, to create a one-off version of it and see if people are going to buy it, is extraordinary. And it's the speed of innovation, the speed of creativity, and the speed of money and business is just accelerating. Literally, it's dials pegged. I feel it. I think you probably do too.
Yeah, for sure. Yeah, there's some great examples of entirely new ways of doing things. I mean, it's obviously classic at this point, but what Tesla did, amongst other things, is produced a car that was radically simpler from an engineering, a manufacturing, and a service standpoint. Right, an electric motor is very, very simple compared to an internal combustion engine and a multi-speed transmission and so forth. So that's an idea where somebody said, in the end, the product will look the same and you'll still get in there and put your foot on the gas pedal. So it kind of, conceptually work the same, but everything is different. And it's a very disruptive, radical move. And so I think there are many opportunities with AR, with 5G, with connectivity and, sensors and so forth, AI, to really rethink a lot of products and have them work differently. A good example maybe there, another customer, iRobot. Many of you know the little Roombas and so forth that buzz around your apartment or your home cleaning. They're now mapping out the space of your apartment or your home again, so that they can do spatial analytics and find the best toolpaths, if you will, to go clean that place next time around. I mean, it's really interesting to see the computing power being put to work in a little vacuum cleaner, to make that vacuum cleaner like far more efficient. Kind of, it gets better and better as it goes. Every day it completes the job a little quicker.
More computing power than got us to the moon.
Yeah.
Claire, I think we have time for one more question.
Yeah, we have one more question here from Remy, who asks, when you look at PTC's clients, what percentage of the manufacturers that you work with are fulfilling their potential in terms of available technologies and convergences? And then a follow-up, if you had to isolate one low-hanging fruit technology or system that most manufacturers are neglecting that could multiply productivity, what would it be?
Yeah, well, let me say, so we have, 30-some thousand customers. Here's the problem. Even if some customers are really at the cutting edge in one area, they may be far behind in another. So if you said, well, which of your customers are at the cutting edge in everything, you do, everything they do, I would say none of them actually. But I think they're all on journeys, and they're in different places in those journeys. Some are very enlightened and trying to go as fast as they can on multiple fronts, and some are dipping their toe in the water in one area to try to see what this digital stuff's all about. Of course, if there are customers, they have some digital, at least in maybe in engineering or whatever. But definitely it's a journey, and nobody's at the other end of it. I can't name a company who's fully 100% digitized. I think there are many different spots on the journey there. If you ask, like, what's the biggest, most important thing? I'll give you maybe two different answers. One, good old boring PLM. It turns out if you're going to have digital representations of your products, and your products are highly variable, and you don't have configuration management wrapped around the processes of engineering, manufacturing, and servicing these products, it's just chaos. So sort of like a building, like imagine software developers writing software without configuration management. It'd just be, every version would be corrupt and wrong and reintroducing bugs and so forth. So at one level, like, having a good product lifecycle management, configuration management system for the digital product definition is absolutely paramount to accomplishing much else. At the other end, I think that augmented reality, virtual reality will prove to be massive, groundbreaking technologies. I think we're starting to get a peek at the power. And I think in the next couple of years, it'll become really obvious that that's not only interesting for engineering and sales and manufacturing and the whole customer experience and the features of the product, how you service and support it. I mean, it's going to be a big groundbreaking technology, and it's coming really, really fast. So that's probably what I'm most excited about, just in terms of the kind of aha moment when you experience it.
Well, Jim, thank you. And everybody, please, Jim Heppelmann, CEO of PTC, thank you for sharing a vision of the future of, well, the current state of the future factory and where things are going as we have converging exponential technologies, making us more efficient, making our supply chain, allowing companies to onshore, and actually helping, I think, frontline workers. I think it's a really important point that PTC doesn't talk enough about. You have the potential to really help frontline workers keep their jobs and actually move themselves up to a higher level of contribution to society, which I think in this era of concern is a really important value add. So thank you for that. Appreciate that.
Great. All right. Well, thank you, Peter. Thanks for the opportunity to come and join you here.
Yeah. Thank you. And if you stick with me a second, Jim, I want to ask you a question after we're off here. But everybody, our next webinar is going to be with Harpreet Singh. He's the CEO of Experfy, partner with Deloitte. Experfy is an on-ramp. If you're interested, how do I get started with AI? How do I actually, what do I do? What data do I have? What data do I need? What algorithms can I create to help me in my marketing and my customer service, whatever it might be? Experfy is a community of thousands of data scientists that he can match up with you and help you get that. So it's going to be October 8th at 10 a.m. Harpreet Singh, CEO of Experfy. See you guys then. Everybody watching us on social media and in the Abundance community, thank you for joining us. And again, Jim, a pleasure to spend time with you. Thank you.
Thank you.